talking about clustering. Sorry for the nightmares. You don't need the projector on.
Good evening, everyone. How are you today?
Good. Great.
Oh, excellent. So I do really well in interactive discussions. My name is Chad. I'm going to be talking to you a little bit about clusters. I'm going to start with a very general overview of what they are, and we'll get into some technology as we move along. Please interrupt. Please feel free to shout out if you want to raise your hand because you're polite, fine. But I do a lot better with a little bit more interaction. So the question is, what's a cluster? And basically, at the most basic level, it's two or more machines acting as one machine. It's pretty much the opposite of virtualization. Those two technologies actually work very well together and are very commonly used together. Any of you ever used Amazon's cloud or Google's? That's basically the two technologies coming together. Amazon or Google has lots of physical servers that act as a single machine. Then they give you off a piece of that, which is virtualized. And that's basically what we're talking about when we merge the two technologies. So from our perspective, there are two types of clusters primarily. There's a high performance cluster and there's a high availability cluster. Now high performance, you've probably heard of supercomputers. It's basically all they are. Lots of computers strung together and working on a single problem. We had back in the 80s, maybe some of you remember, you could download a little program and help SETI study the sky or break the human genome. And of course, as the top 500 fastest computers in the world, those are all just basically clusters working on a single problem. High availability clusters, on the other hand, are lots of machines working together that if something breaks, they can continue working. Content delivery networks are a very good example of that. So basically, all you have to have for a content delivery network is two machines with the same content. Let's say somebody wants to go out and get google.com. It's a static page. They go out and get it from place A or place B. Doesn't matter where they get it from. If any of you wanted to build your own cluster, there's a very simple way of doing that. All you have to do is a little round-robin DNS. You add two IPs to your DNS entry. It'll go to machine A or machine B. As long as they have identical content, you can browse either machine and get the same exact thing. And that's all we're talking about doing, is having one or more machines acting with another machine to present the same thing, so that you think you're operating on a single machine. So, one of the reasons that I got into clusters is I was working for a company, and we had a single computer that did everything for the business for a mapping company. And there's sort of two philosophies that we were kind of talking about. So we're all mammals. Mammals tend to take very good care of their offspring. They have a very small number of them, and the parents take care of them, and lots of nurturing and feeding. Google has a different approach. They have the insect approach. Have millions of offspring, and just let them out into the world and let them fend for themselves. So in the Google data centers, they have lots of machines. If one of them dies, they just turn it off. They don't bother fixing it. They don't even go look at it. They don't even try and figure out what's wrong with it. They don't care. They just have lots of machines. So clusters are basically the insect theory. Instead of having to have lots of care and feeding and paying attention to your machines, if you just have enough of them, you don't have to worry about that. When one of them is out of service, you just take it offline, and the rest of the network continues. So the idea there is, for those of you who like to sleep at 2 in the morning, if you have a single monolithic machine and it goes down, lots of phone calls, lots of text messages, and you've got to get up and go deal with this thing. You have a hardware problem, it could even take days to get replacement parts. So, you've got two machines, you got a hot spare maybe, you run down, you swap out a few things, and you're back up and running. If you have them in a cluster, they just fail over automatically. And we do that through load balancing. So there's a few different ways to load balance. We can load balance with application devices that are specifically designed to do that, or we can build our own. Linux actually has a built-in load balancer, the LVS system, and on top of that is something called KeepAliveD. KeepAliveD is what we're going to talk about today for our load balancing and the examples that I'm going to use. Now KeepAliveD can load balance several different types of technologies. I'm primarily going to talk about HTTP because that's just a very simple, most of us understand it. Everybody here has used a browser, so you get the idea. Now, what happens is you have a load balancer. Since we're talking about high availability, we'll always have 2 or more machines in any given role. So you have two load balancers that are sitting there together. And they're talking to each other with what's called a heartbeat. When one of them fails, the other one says, oh, you just went away, pulls its IP and says, okay, I've now taken over, and it will continue sending traffic through that load balancer now. If you have 6 or 8 of these together, no problem. You can even have them be active-active. If you have 2 or more, you can have, as an example, each one has its own IP, and you have round-robin DNS or some other divisible technology. And so you can have active traffic coming into each of your load balancers. When one of them goes down, then all the traffic fails over to the others that are left alive. So you can, in addition to that, you can add priorities. You can say, this is my primary, it has a higher priority than the others. If it comes back up, I want to roll all my traffic back to my primary. But you can have outages that way. So a lot of clusters, mine in fact, if the primary fails and we roll to the secondary, we stay in the secondary and it just becomes the primary. When the primary is repaired, it just stays as the secondary. Because I don't want the lag time of rolling back over to the first machine. So I just leave that second machine as primary now. If I'm doing maintenance, I can of course switch back over if there's some reason to do that. But for the most part in my clusters, I never do. I just roll over, that guy just takes over, I have equivalent hardware, so it's no problem. If you want to test this yourself, you can do it very easily with some virtual machines on your computer. The key is you need to have at least 2 network interfaces. So you have to have one on the internet side or the public side, and you need to have one on the private side. Now, in this clustering environment, there are a few ways that you can handle the traffic through the load balancer. So there is one method, which is called NAT, which all the traffic comes into your load balancer, comes out the back of your load balancer into your cluster. The cluster communicates back to the load balancer, and then back to the end user that made the original request. So all the traffic in both directions is flowing through your load balancer. Your clustered machines behind don't need to have public IPs. Aaron likes us. We need one IP on the outside. All of our private machines are on private network. They don't need public IPs. Now, if you are doing a lot of traffic, then you can get a bottleneck at your load balancer. So they created what's called DR, which is direct response. So direct response means the inbound request comes into your load balancer. It determines that it's going to send it over to one of your machines. That machine gets that request, and it responds directly through its own IP back to the original person. So it does not, the traffic going outbound does not go back through your load balancer. It goes around and back directly. Now, the advantage of that is you have a lot less traffic, in fact, half as much traffic on your load balancer. The disadvantage is you need lots of public IPs now. In addition, it can be very tricky if one of your machines goes down, and then when it comes back up, it doesn't ARP. So it's got to be careful not to take over the load balancer's IP. So there's some tricks there that you can do in the configuration files to tell it on your network interface X, do not ARP your IP out, because it's spoofing itself as the load balancer when it responds back. So in my environment, I use NAT. All of my traffic goes through. I don't have a high enough volume currently in my cluster. I have run a DR cluster though, and it's very effective. We did about 1 billion HTTP requests a day, topping at around 120 million an hour at times. Very, very fast, 100 machine cluster. Now, I like to have at least 4 network cards in all of my machines. Okay, so I have 2 for the public IP on the load balancer, 2 for the private IP. And then I put those into a bonded pair. Now, lots of different bonded pairs. I typically just use a simple failover unless I need the higher bandwidth for some reason. And so that all the traffic that comes in, I have 2 network switches at both locations, so I have full redundancy. Anything fails at any point in the chain, I never have a single point of failure because I have 2 of everything, including network cards in the machines. Network cards are pretty cheap. You know, if you can get a machine that has 2, you can throw in a card with 2 more on it for, a used card for even 20 bucks. I mean, it's not very expensive. So why not do it? This is the insect theory. I can get a bunch of commodity machines at 250 or 300 bucks a piece. I can build a stack of 40 machines for under 10 grand. So you don't have to have these big, powerful, expensive machines now because you're dividing the load between 30 or 40 machines instead of between 1 or 2 machines. So I'm working for this company. We had a machine, just one. All the traffic came in, no problem. We're serving up requests, serving up requests. We get to 80, 85% of our total capacity. And we decide, okay, we don't want to get in trouble here. In case we have a burst, let's go buy a new piece of hardware. We go out, buy a new machine, 10 grand, put it in service, move all the traffic over to it, no problem. And we go along another 6 months or a year. Oh, we're starting to get near our capacity. We decide to buy another machine, swap it out, bigger machine, bigger machine. So one day, it's only been like 3 months. Sales team was kicking butt. We suddenly had a bunch of traffic. It's okay, we need a bigger machine. Intel hasn't made a bigger chip yet. What are we going to do? And that's how we started our first cluster. We said, we don't have a choice. We've got to divide our traffic between more than one machine. We simply can't buy a single machine that has enough capacity. Now, that was many years ago. Probably everybody in this room, just because we're all nerds, everybody in this room is probably using clusters today. Anybody have a Gmail account? Anybody have an iCloud? Anyone using any of those free email accounts? All of your email is sitting on a cluster somewhere. There's not a single machine sitting there serving your mail. You know, they have a huge data center with tons of traffic on it. So it's become much more commonplace. And because of that, the technologies have also grown. So when we first did our first cluster, you know, LVS was it. You had to go at the Linux command line and know how to configure that. And then very shortly after, the Linux High Availability project came out. And they created something called Heartbeat. And you could install Heartbeat with Deb or an RPM. And you could use that to configure the LVS system, which was fantastic because it made things a lot easier. There was now a config file instead of having to type a bunch of commands at the command line. So you could set up your config file, you could copy it to other machines, and you know, life was great. So that's what we're doing nowadays when it comes to clusters, is we are taking that to the next level. We have infrastructures and frameworks. We have OpenStack, and I think they have Eucalyptus now. There's a few others that are out there. Apache has their Hive, I think is what they call theirs. And you can now install these, and they will help you set up the different types of nodes, because we've talked about the load balancer, but we also have the compute nodes, which are the nodes that are going to be, in our case, serving HTTP pages. But we also have database nodes. We also could have block device nodes. So there's a few different kinds of things that we might have. Management nodes. You might want to deploy machines automatically, so you might have deployment nodes. And so when we start talking about those technologies, the community has realized that this is something that is needed. We need a framework to help us manage that. So when I started, you just had to remember. And if you wanted to run a command, you had to log into each individual machine and run it, or you had to get something like a parallel shell. So you know, those did exist, or you could write a little shell script or some other program, and you could run those commands simultaneously on all your devices. So the next piece of our cluster, for our web cluster, is the content. We have to keep that content in sync. We want all the machines to have the same content. Now, at the most basic level, we could do something like, we have our master node that has all the files, and we rsync those files on a regular basis to the other nodes and keep them in sync. And that does work. And there are actually some significant advantages to that, which is each individual node has 100% of the files and is not reliant on anything else to be able to serve that data up. But nowadays, we are a little more sophisticated than that, and we typically don't do that in all cases. Typically what we'll do is we'll have some kind of network attached storage or SAN. And those can be commercial devices, you know, EMC, or you know, you can buy a NetApp device, or of course there's plenty of open source alternatives. You know, there's Gluster and Lustre and Hadoop, and Ceph I think is out. It's getting more popular now. So there are a lot of choices there, and there's a lot of advantages to doing that, because now each of your compute cluster machines can be even smaller. They only need hard drive enough to contain the operating system and config files. So they can also be faster, because now we can put SSDs in them because it's very cost effective, because you only need a $50 SSD. You don't need a 2 terabyte drive that's running $600. So those types of technologies is what's helping the cluster be common for small and medium-sized businesses, and not just the giants like Google and Amazon. So the idea here, yeah?
So that accounts for the front-end traffic, but what about the database at the back end? Presumably there's a database behind this, otherwise you're serving on static stuff.
Correct.
That has to be updated, and how are you distributing that? Or is that
So that's a good question. And so you have several choices there. So let's start with the most basic, which is you run a single database server. Now, of course, I'm talking about clusters, so that's bad. We wouldn't want to do that. But you can run a single machine. And you can sync that machine to a secondary, and you can have them fail over automatically, and you could run it that way. But we also now have database clusters. If we just talked about MySQL, which is one of many choices, there's actually 4 different clustering technologies that I know of that you could use with a MySQL cluster that will clone your data in real time. You can do reads and writes to any of the machines in the cluster. Now, the way that I handle that in my cluster is I have 5 database machines. I have them linked together. They're a Percona cluster in this case, which is an open source cluster technology that sits on top of MySQL. MySQL has the MySQL cluster, which you can get from them directly, and there's several commercial versions as well. So that cluster sits there, and it has a single IP. I then have a load balancer in front of that, a pair of them. My traffic comes into the load balancer and then gets doled out to one of those 5 machines. So I'm doing the exact same thing that we're talking about doing on the HTTP side. I've just flipped it around on my private network, and I'm sending the traffic through to my database the exact same way. So that's the next level, actually, so I'm glad we're there. So the idea is you have content, whether it's in the database or it's in a file system, and now you're sharing that data across the entire cluster. Now I like to have 3 sets of networks. So I would have what I call my red network. That's the internet. It's red, it's dangerous, we don't trust any of the traffic, we lock it down as tight as we can possibly lock it. Now we have another network that's between the load balancer and all your other machines. So the traffic comes in, and it has at least some modicum of scrubbing in the sense that not any traffic can come through. The load balancer only lets through certain traffic, in this case HTTP traffic. So that traffic is slightly safer. So that's what I call my yellow network. And then I have a third network, which is my green network, which is not connected to the internet at all. It's a private network that's between my machines. That's how my database machines talk to each other and stay in sync. So that traffic is safe because it's never exposed to the outside world. It's held back inside of a third layer of network. So for those of you who might be network guys, you might have a 192 network in between your load balancer and your HTTP servers, and you might have a 10 dot network for your database servers. And you can have more than one of those private networks. You could have one just for the database servers and a different one just for your content network or your SAN. So you can separate out that traffic and keep that security on each individual part of the cluster. So in this case, the goal is to keep the cluster up all the time. That's what the high availability piece means. So again, at any point in the stack, we want to have at least 2 or more devices so we don't have a single point of failure. Now, that includes the humans. Don't forget that if you are a system administrator and you are working on something, to document it, because there's probably some other system administrator in your group who may have to deal with that thing when you're not around. So we want to think about it in its entirety, not just in the individual pieces, but the individual pieces are very important because that's ultimately what drives what the stack can do. So if you have traffic coming into the network and you're dividing it out, there's a few different ways to do that. You can divide it out round robin or least connected, and there's a few other strategies. Now I found that if you try and be too smart about dividing up your traffic, you can create a very high load on your load balancers. So your load balancers can be very inexpensive, very cheap CPU, because for the most part all they're doing is forwarding network traffic from point A to point B, and they don't have to do a lot of thinking. Now, if you use least connected, now the load balancer has to check each machine, see how many connections each machine has, and it has to know, okay, this one's least connected, send this piece of traffic there. But when you get very high traffic, like 100 million hits, that takes a lot of computing power. And if you just go round robin when you have that level of traffic, it'll be fairly even anyway. You don't really need to play with it too much and be too intelligent about it. Now, there's another strategy you can use. It's primarily used for databases, which is called sharding. And the idea behind sharding is that if we take our data, whatever that is, we can run an algorithm against it, and we can decide that that algorithm, that data, is always going to land on this server. So we do some math on it, it comes out with number 3, it's always going to live on machine number 3. So now you can divide up your traffic that way, and you can send traffic for that specific data to that specific machine. The disadvantage is, what happens when that machine goes down? Yeah. So we still need to have a strategy about having that machine have its redundancy, but now you can divide out your traffic in a slightly different way so that not every machine has to have every bit of data. And that can save you some hard drive space. It can save you some network traffic. I don't have to take this piece of data that I just wrote to database A and copy it to all 4 machines or all 5 other machines. I can just put it on 2 machines, the primary and its backup. So there are some strategies there about how to make the cluster more efficient. And the beautiful thing about all this stuff is it's all open source, it's all free, it's all available. You can play with it and learn it and figure it out and determine where that would fit into your stack, if anywhere. So, other questions? Good point for that. Okay, so we talked about a few different ways of doing load balancing, and we talked a little bit about the network. There are a few other things that we have to deal with, like building machines. So, are any of you familiar with any of those technologies, like Cobbler or Satellite or any of those? Pixie booting off the network? Okay, so maybe some of you are familiar with some of the configuration tools, Puppet, Salt, OpenVenus. Anyone? Okay, so so basically what we're talking about now is you have a lot of machines, right? Well, at first when you get them, they're just bare metal. They don't know nothing. They don't even have operating systems on them. So we need a way to deploy those machines. So we would create a deployment node, and that would have the operating system. It would have some sort of Kickstarter file that tells it, what its parameters are, what hard drives it's going to have, how it's going to be configured, what type of node it is. Is it a database node? Is it a computing node, etc. The machine would then boot. It would get its DHCP. It would get its configuration and operating system off the network. It would then come to life. It would then call home again and get its configuration, and then it would get any content that it needs, and then it would come online. Now the advantage of doing this, think again, Google, hundreds or thousands of machines in a row, and there's hundreds or thousands of rows in the data center. You have to have a way to deal with that automatically. No human can deal with that by themselves. It just isn't practical. Now, for those of us in this room, we probably aren't talking about that scale, but the advantage of doing it with an automated deployment is that you make fewer mistakes. We don't forget commands when it's automated, right? We put them in there, we know it's going to run each of those commands in order. We know if we need it to make a change, we can make it once, and we can push that out everywhere. So there's a few technologies we can talk about there. So Pixie, which is PXE, is network booting that just basically has your machine go out, look and see if there's a Pixie server. It'll get a DHCP IP, and then it normally will give you a small kernel that it'll boot with a menu, and then it'll give you some choices. Do you want to boot it manually? Do you want to boot to the local hard drive? Or do you want to boot one of these images? Now, it will normally automatically time out and do whatever the default is. Be very careful about setting the operating system installation as the default. Mm-hmm. This machine can now get into a loop. It reboots, it installs the OS, it reboots, it installs the OS, and on we go. So you got to be a little bit smarter about how it behaves and what the machine's going to do and how you have it configured. And of course, Windows has helped us with secure boot, because that's what we love. So that also can make it a little more challenging. You have to switch your BIOS sometimes before you deploy one of these machines. Now, once your machine is up and running, you have to configure it. Now, I have selected Salt for my configuration manager. Each of these machines calls home, says, hey, here's my MAC address and my key. It generates its own key just like an SSH key. It calls home and says, hey, I'm a web node, or I'm a database node. And then the configuration server sends it all of its information, makes sure its services are running, makes sure any packages it needs installed are installed, sets up its host file, all that good stuff for it automatically. Now, of course, as time goes on and our needs change, we change those config files. And the wonderful thing about that technology is you can just tell it, push all these changes out for me. Now, we test them first, right? Everyone here, we always test, everyone tests, right? Anyone here never tested a one-line change? Oh no, no one does that. So the idea is you test your changes, of course, and then you send your changes out into production. Now I like to do a development node separate from the cluster to give my developers a chance to go in and mess around and screw things up. And then I give them a staging server so they can push their changes out one more level, and they can mess around and play with that. And then when they're happy with that, then they can push it into production. And now I keep those two levels as nearly identical to the production as I can. So if I have a load balanced database for production, I have a load balanced database for development and staging. And this is where virtualization comes in. I got a stack of 40 machines for production. I don't need another stack of 40 machines for staging and another one for development. So we can just put a couple of virtual machines out there now, and they can act like our big stack without having to buy that hardware. And that's where those technologies work really well together. Sorry. Now, all these technologies that I've talked about are available in free and open source versions as well as commercial versions. And depending on what your needs are, sometimes the commercial version makes a lot of sense. I stepped into an environment at one time. They were running all Red Hat licensed everything. And they were spending quite a bit, actually, on just their licensing. So they're spending about $20,000 a year just for their server stack licensing. And I went to the director of IT, and I said, okay, we're paying for this. Let's call Red Hat and open a ticket, I have a problem. And he said, well, how do you do that? And I said, what do you mean? And he says, we've never done that before. I said, so let me get this straight. You've been paying them $20,000 a year for this, and you've never called them. Nope, we never called them. Why are you paying them $20,000 a year? Well, that's what you do, right? You need a commercial product. Not exactly. So, as some of you may or may not know, CentOS is their free and open source version. It is binarily identical. You can save yourself all those licensing fees. I think there are a lot of advantages, especially for a larger company that maybe has some junior developers and junior system administrators that need that support. But if you're not going to call them, or you're going to call them 4 times a year, just pay their $250 an hour rate. It will cost you a lot less than the license will. So think about when you're planning out these things, what's going to be the best, not just from a technology standpoint, from a business standpoint, which is when does it make sense to spend that money? There's definitely times when it makes lots of sense to spend the money. Getting support from somebody who knows that technology inside and out and can walk you through how to get more out of your resources is always a good thing. Just don't keep paying for it when you're not using it. So, in addition to the cluster being able to respond out to HTTP requests, it can do lots of other things. So let's go back to talking about Keep Alive D, which is our load balancer. Now that technology will sit in between the internet and its requests and your web nodes. Now, how does it know that your web nodes are alive, right? It needs to somehow check them on a regular basis. And in fact, it normally does that in a very short time period, like 1 or 2 seconds. And it makes a simple request. Now each of those requests then gets hashed, and it just compares the hash key to whatever the machine answered. Now, I recommend that you do not just use a static web page. You can use an HTML file, just a straight up page, and what you'll basically be checking is that your web server is up and that it can serve that one page. If you use a CGI program with whatever application language you're using, PHP or Perl or Ruby, etc., then you're testing something else, which is, can your web server deploy that particular CGI script? Because there are times when you make a misconfiguration and you can serve HTML, but you can't serve your application. So perhaps you're doing fast CGI and your application server, which is sitting separate from your web server, has gone down, and now the load balancer knows that, takes your node out of service, and sends you an alert that, hey, this node went down. You go, wait a minute, my monitoring didn't tell me that node went down. My monitoring didn't tell me that my web server, which is Apache or Nginx, etc., they're all up. Why is this suddenly down? Oh, your application server went down, your load balancer knew that and stopped sending traffic there. So you've got to keep in mind that you can do things in different ways and get different results, and sometimes there's an advantage to just getting a straight HTML page, especially if you have a resource-limited machine, and you can have different levels of those machines. We call that weighted connected. So you could say this machine has a nice big CPU, its weight is 100, and this one, it's not so powerful, we're going to give it a 50. And now, out of every 150 requests, 50 will go here and 100 will go over there. And you'll serve twice as much traffic from one as the other. Now, I know a lot of guys who like to use low numbers for that. 2, 3, 5, 10. I recommend you pick a very high number, like 100, so that you have a little more granularity, and when you make a change, it's not so dramatic between the two machines. If you have a 1 and a 2, you've just created a doubling effect. If you have 100 and a 99, they're a lot closer together. So depending on the volume of traffic, you want to adjust those, and you can even go higher. You can go to 1,000 if you need that much granularity. So now we have our load balancer. It's talking to all of our web nodes. It's checking to make sure they're alive, and it's logging that, and it alerts you when it's down. And it's heartbeating with the other load balancer. So we have a little bit of redundancy there. And of course, you have multiple network switches at each level, and those are bonded together in some way. And now we get to the database.
Can those numbers be the same? You said 1 and 2. Could they have both been 2, or could they have both been 100, or both
Absolutely,
1,000?
and in most cases they are. So
Okay.
if you buy a stack of identical hardware and it's configured identically, then yes, all those numbers would be 100. And then, say 6 months or a year later, when you buy new machines and they're a little faster, those stay at 100 and the new ones come in at 120 because they're 20% faster. And that's one of the advantages of using 100 is it's pretty much percentages, so you can adjust it pretty easily that way. Good question, thank you. So the database. So in my environment, I have a cluster of machines that are serving up my database traffic. I did learn something about Percona. In case anyone here ever considers using a Percona cluster, you cannot use MySQL dump. The end. Just don't. It will crash your cluster. 100% it will crash your cluster. Maybe not the first time, maybe not the second time, but I guarantee you at some point it will crash your cluster. They have their own technology for doing dumps. So you have to make sure you deploy their technology. And it's the same technology, I shouldn't say the same. It's one of the technologies they use to keep the database in sync. They allow several different things, including rsync. If your data is very slow growing, very slow changing, you can keep them in sync with rsync with that technology. They use something called extra backup, and it syncs in real time, and near real time, of course. And because of that, I keep that off on its separate network so that I can monitor when they're starting to get near capacity. I can add more cards to the bond, or I can go up to a 10 gig connection if I need to, because you don't want that traffic to be slowed down, because if one machine is slow syncing, the other machines have to lock and hold their traffic for that same row, and so you have row locking now in contention. Yes?
Can you rsync InnoDB tables as well?
Yep, absolutely. So Percona only works on InnoDB tables. If you put MySAM tables in it as an example, then they won't sync properly and you have problems, because they need row level locking, because that's how they do everything, is they do a row level lock, they commit it to the other machines, and they release the row. So that's essentially how they're doing it. And so if you rsync that across, you just have a bin log that you're basically rsyncing to the other machines, and then they read it in and they update their rows. You've just created a little bit more time delay, because the file has to get copied to each machine, and then the machine has to load it. So the extra backup is a more real time. They actually deliver transaction to each of the databases in the stack. So in the database stack now, we have a load balancer. Now in my case, Percona does not allow a keep alive D load balancer, which is what we've been using for our web traffic. It requires HA proxy, which is how I got into this talk, by the way. So the question was posed, does anyone here use HA proxy? I said yes, and does anyone want to give a talk? And I said no, because I use it for a very, very specific thing. So I use HA proxy for my database load balancing. So traffic comes into the HA proxy load balancer in this case. It decides which machine to send the traffic to, and it checks that each of the machines is up in a very unique way. So HA proxy is specifically designed for HTTP and for HTML, and so it doesn't know anything about databases. It doesn't know how to check on 3306 and find out if that database is up. So they have created a little program that when called, it's essentially a CGI program, that when called, it checks, and then it just returns back a status of okay or not okay, at the very most basic level. And HA proxy just calls that CGI program. That CGI program runs a local command to say, hey, is MySQL up? Yes, it is, and it just returns an okay, and then it keeps it in the cluster. And when that goes down, then HA proxy kicks your machine out, you get a warning from HA proxy, and it sends traffic to the remaining machines in the cluster. Now, this is where you have to be careful. In a database cluster, when you're bringing up new machines or bringing a machine back into service, there's typically a period of time where it's out of sync with the rest. Some of you may know that as Splitbrain. So what's happening is that machine doesn't have all the data, or its data is out of date, and we don't want to send traffic there, so we put it into a special mode that says, hey, I'm coming up, but I'm not up yet. And the HA proxy will read that as down. It will not send traffic there. And it will try and go out to one of their machines and say, hey, I need to get in sync, give me your log file, and I'm going to run all your transactions and get up to date so that I'm equal with you. Now during that process, depending on what kind of machines you have, the donor machine that's sending all those transactional data to the machine that's coming up is slowed down. And they have a mode that allows you to take that donor out of service as well. So you can say, my donor is out of service, it's only accepting updates, it's not accepting requests, and it's at the same time feeding that machine to get it built back up, that new machine. Now, the problem with that is, if you have 3 machines in your cluster, and one goes down, and one is a donor, you're down to 1 machine. Now, we don't like that. We don't ever want to be in that condition. So my advice is to either have big enough machines that your donor can still serve traffic, so divide the traffic enough and reduce the amount enough, and even though, yeah, it's a little slower, it won't really affect your performance enough, or have more machines. Go with the insect theory. Instead of having 3 machines, let's have 6 machines, let's have 8 machines. And now if you have a couple of machines that are down, doesn't matter, because the percentage of machines in your overall database computing power is reduced by a factor of the number of machines.
So are you load balancing your writes as well?
What, the writes, the permissions?
Yeah.
No. So my environment is too small for that, but you certainly could, and that's where sharding actually would make some sense. And not just per machine though, I would shard off a permission set so that you have these machines serving these higher permission levels and these machines serving the lower, and that way there's no chance of having bleed through between the 2 systems. So if you have one of your lower users that somehow gets elevated privileges, they can't cross to the other cluster anyway, because it's on its own separate network, it has its own set of load balancers, its own IP. So now you cross the privilege threshold, there's nothing there, because it's on a separate cluster. And again, the goal is to have super inexpensive machines. So you have 10 of them, you put 5 over here and 5 over there because they're not expensive. And that hardware, you know, nowadays, I mean, you can buy some of that old, you know, L5640, which is an Intel CPU with 6 cores, and you can get a machine literally for $250 with 32 gigs of RAM. Now, you're saying, well, this is a database machine, hard drive, hard drive, hard drive, that's what's important. Yes, except that if you have enough of these, your request pool is so small that you really don't have a bottleneck because the traffic is actually being shifted to the network as opposed to the machine's hard drive because your request volume is so much lower. Does that address that? Okay, so that's pretty much how I deal with the load balancing of the database. But the database needs a lot of maintenance. You got tables that grow, and you have hard drive constraints, especially because, again, we're trying to buy these smaller, inexpensive machines. Now, all the database machines, I still do RAID 10. I don't want to take any risks with my data. The advantage of being in the cluster is you don't have to. I know a lot of guys that'll do like 3 hard drives in a mirror, which is good for redundancy. You don't get a lot of performance out of it, but again, you don't need a lot of performance because you're reducing the volume of traffic to each of the individual database servers. Now, network becomes very important because you're transmitting that data to all the servers and getting the confirms and the writes back and forth. So you've definitely got to have a really good network between your machines so that if your volume is high enough, even though the hard drive isn't being stressed, your network will be. You'll have lots of traffic through that. So make sure you have a lot of bandwidth, either bond more cards together or go up to a 10 gig, etc.
I'll
all of your database at this point is MySQL. Are you using Postgres?
So I'm not currently, but I have. And the thing that I like about Postgres is it does have built-in master-master, which is an advantage. It's essentially clustering by itself. So it does have multi-master mode. And I like that it is more Oracle compliant. It's closer to SQL 92, etc. And it's more atomic in the sense that MySQL is a little bit fiddly about its transactional commit. And so Postgres tends to be more reliable for atomic operations, which I like. My environment it doesn't need that level of commitment. And MySQL just has so much more support and community behind it. It was a lot easier to deploy that. And that is another thing that I would like to point out for you. I'm an old school guy. I've been using Perl for a really long time. There's probably a lot of you in here who just took a, oh God, Perl. But I've been doing it for 20 years. So, I mean, that's what I'm familiar with and that's what I'm used to. I had a junior developer that was talking to me and he said, you know, why did you pick Perl? And, you know, in the day there was a reason, I don't even remember it today. And he said, well, should I pick Perl? And I said, you know, that's a good question. And what my advice to him was to go out and see what he could find for community support. Because let's face it, when you're in trouble, yeah, maybe you've paid somebody to give you support, but odds are you haven't. You're going to go out into some forum, you're going to go out into some chat room, some IRC, and you're going to ask some human out there, one of us, to give you a hand and see if anyone knows what's going on. And so he got very excited about that. And he went out and he developed a spreadsheet which included how many questions were asked on certain bulletin boards and how many GitHub pages there were for certain things and how he could define how big the community was. Now he landed on Ruby. He thought Ruby was just the bee's knees. To be quite honest, I believe languages are languages for the most part. There are advantages and disadvantages to all of them. Pick the right tool for the job. Beyond that, I don't really care what it is. Windows, Linux, etc., same thing. I'm very agnostic in that way. If the right answer is the right answer, then who cares who wrote it? So I tend to be that way. I know there's probably a lot of people here who are very diehard in their beliefs and what applications they use, and this is the right way, you should always use this. And I'll do that sometimes. I'm right, you're wrong, just get over it. But the reality is that, you know, different tools just make more sense depending on the environment. And community support is actually a very big thing in my opinion. When you get in trouble, you know, if there's only 6 other guys in the world that know what you're doing, I hope you know those 6 guys, because otherwise who's going to help you? And so when we're talking about these clustering technologies, I'm trying to let you guys know that there are lots of choices out there. Find the one that best meets your needs. And that each of these individual components, Postgres versus MySQL is a perfect example, is something that works in the cluster, but it also works in almost every other stack that you're involved in. A single monolithic machine that you decide, hey, you know, my cousin said he needs a little email help. All right, I'll just deploy a VPS and, you know, I'm going to throw SendMail on it. Oh, did he say SendMail? I meant Postfix. So, you know, it just, what do you know? What's the best tool for the job that works for you? You know, and what technologies are going to be familiar to you is what you should use in your deployment. So if you already know Postgres and you're really good at it, you're really good at Oracle, there's no reason not to use those same technologies in the cluster. You just have to make sure that there is a way to group them together. So Oracle has clustering and Postgres does as well. There's lots of choices there. And in fact, the technology that Percona uses works for MiraDB as well as Postgres. I don't know if it works for Oracle. Any other questions? Okay, so anybody here running a machine as a system administrator? Any sysadmins here? We got a couple, okay. So, and do any of you have a stack of more than one machine? More than one machine, okay. Do you have more than one operating system? Do you have Windows as well? You have a mixed Windows and Linux? Okay. And in those environments that you guys are now thinking about and you're learning and you're living with, how many places have you had a failure where you have a bunch of problems because something went down, whatever that something was? So we've all had a call, right, at 2 in the morning, and you schlep yourself out of bed. So the question is, what could we have done differently in that environment with those resources to not have had that failure?
Actually, I find now you have more problems with network routing issues from the provider than
So
machine failures.
that is an excellent point. So what do we do about that? Anyone here heard of BGP? Okay, so there are solutions to that as well. Have multiple network providers coming in. You have those IPs coming into your load balancers or your routers in front of them, depending. And then, you can now do clustering of that network IP across two different providers. Because you are almost always at the mercy of the data center, the ISP, the power company. Someone in that realm always is going to be your biggest problem because it's out of your control. No one here, as far as I know, is running the power company. So when the power goes out, that's it. You've got to deal with that. How do we deal with that? We deal with the generators, we deal with the batteries. This is no different. The question is, how do we deal with those single points of failure to create high availability? Now that's all a cluster really is a way to take a bunch of machines and string them together so that if one of them fails, the other ones handle the load. Okay, I'm running out of steam, guys, I'm sorry. So the big thing here is to figure out at what level you want to do the maintenance on these things. So we talk about Google, they don't even bother. Something dies, they just say, okay, just turn it off, that's it, that's the end. But in our environments, my guess is most of us, somebody cares about the money and somebody cares about the hardware, and that someone's probably you or your boss.
So are you doing anything with physical location dispersion to prevent something like, I don't know, a power outage, crashing
water fire,
your world light operations or something?
Yes, so I don't deploy in California where there's earthquakes. No. So I do not currently. I'm just not big enough. I literally just can't afford it. I have a single full rack. It happens to be in Las Vegas, Nevada. And I have dual drops from the ISP, and I have dual power feeds from them as well. So I do have two generators behind those feeds. I do have UPSs in the rack itself. And I do have multiple networks coming in. If there's a fire in the building, or an earthquake, or a terrorist attack, I'm down. I am not also in New York. That is on my list, when I can afford it to deploy at a second location and use BGP.
But it doesn't sound like your installation there is all that expensive. I mean, how much total hardware do you have?
I've got about 40 machines. I spent around $250 per machine. It's not expensive.
Right, I mean, in industrial terms, that's,
nothing.
Out of your own pocket, it might
Yep.
be, but there are a lot of, and so, what would it take then to have it doesn't have to be the country away, but I suppose it could be coast to coast. What kind of network connection? Is that really available? You got your own fiber running there?
So you can definitely run your own, you lease it, obviously, you lease fiber network. But nowadays at most ISPs you can buy 100 megabits or gigabit connection from them, and you can do a VPN between locations. You wouldn't even have to go fiber depending on how much traffic you have. If you have your own campus, that actually might be sufficient. You could be running it in just two separate buildings. So I worked for a company that they had 3 buildings on the property, and they had fiber running underneath the parking lot between the buildings, and we put the primary stack in one and the secondary in the other. Now they were all very local. Everything they were doing was very local. So if something happened, it wasn't like there was a guy in China ordering parts from them. Now, if you are a more public international company, then doing deployments at least a mile away from each other makes sense, but really a separate state. You don't want a natural disaster, which is your most likely thing to take you out if you're in a tier 1 data center. In Las Vegas, there's a data center that I am not in that I toured, but Homeland Security is in there, and their security literally carries M16s, and everybody has to be vetted and fingerprinted, etc. And I thought that was great. They are actually, there are only 2 tier 1 facilities in Nevada. The Hoover Dam is one, and this Colo is the other. And they are authorized at gunpoint to cease fuel to keep that site up and running if necessary. Seems like that's kind of crazy, right? But a rack there, a full rack with power and data and everything, is only a couple of grand a month. It's not that insane, price-wise, to be into a place like that, and they're all over the place. So you get one here, you get one there. You need something bigger, you go to a cage. You can, again, for $5,000 or $10,000 a month, it's not a crazy number if you have a $1 million budget. So it kind of depends on what you're doing. I'm small. I'm running on a small budget. You know, I spend about $1,000 a month on my monthly fee there with them. But the beautiful thing about it is, you know, this scales everything from 2 machines, you know, sit in your basement all the way up to, you know, I've got, you know, 5,000 machines at 6 locations. And it works no problem. You just have to spend the money for the bandwidth to keep them in sync. Now the other advantage you can have when you're talking about multiple sites is if you direct traffic geographically and you keep them on that local cluster, you don't have to have as much real-time transfer from point A to point B. So you can keep all that locally on multiple machines in real time and then sync, let's say, every 15 minutes off to the second site. And that can save you a bunch of headaches, and you're only looking at a 15-minute, you know, window of loss, and then you don't need nearly as much real-time bandwidth between them. You're just syncing up a little bit more slowly. And if something went down, you would take more time to recover. The question is, you know, what is your tolerance for the downtime?
So, do you know what went wrong with Delta and what it would have taken to prevent that?
I know they had problems.
They failed over to a backup generator and it caught fire, and it took a while for the fire to be put out.
That's awesome.
And then it took quite a while to get everything back up once they actually had the generator
So the
running again.
generator caught fire.
Yes, or something during that time. Yeah, apparently.
But what that really sounds like is they did not have a proper testing procedure for their disaster recovery.
This was the testing procedure.
Well, there you go. So.
That's the thing is that's not the first time that I've ever heard of something where they're performing the test.
Right.
And the test fails horribly. Like Amazon has done this on several occasions where they're trying to fail over to the backup UPS and then everything cut as hell.
At Delta, did this happen during a test?
Yeah. Yes, it was.
Yeah,
Or hold on.
It's
I
so
tell you, I just
recent,
had it
I
up.
think we're gonna hear a lot of stuff that's some true and some not.
Right.
Yeah, they just set up the power outage.
Yeah.
It's like, no.
Yeah, that's all they said. Right.
The
No,
details will come
no,
out.
that's not what happened.
Yeah, the details will come out.
I mean, the problem with
a week
it.
from now, we'll know a lot more.
Right. The problem with the airline is real-time data, especially for air traffic control, is absolutely critical. You can't screw around at all with any of that stuff.
But it sounds like they must have been in one building. If they had a shadow or a mirror data center 100 miles away or 1,000 miles away, then they should have been able to just turn that building off and run without a problem.
They probably have multiple buildings, but they didn't realize that one building was still a
Single point of failure, yeah.
I mean, and here's the other piece of that is again, I mean, just like we're talking about where you can shard the data, you could shard geographically. I mean, when you go to Google, we're not all going to the same place. You know, it's figuring out where you are geographically, and you're getting routed to the California location versus, you know, the New York location. And if California went down, conceivably they could just say, well, that half the country is just SOL. Just they don't get anything right now. We're just going to be up over here, and that's actually happened. I mean, Google has actually failed in that way, where a region of the country doesn't get something. There was a famous train accident in Pennsylvania, I think, that cut a bunch of fiber there, and a whole bunch of the East Coast went dark, and the rest of the country just wasn't affected, just didn't even know. So those kinds of things are always possible. The goal is to route that traffic through the southern route and not have anyone notice. It just doesn't always work that way.
Well, there's always also the idea that you want to spend as much as possible on disaster recovery, but no more.
Right.
You know, so you can sit there with 15,000 layers of tinfoil or whatever when you only needed maybe 5 or something like that.
Right,
You're just wasting your money on tinfoil. So, and I'm sure they probably thought, well, throw everything in one data center, that's no big deal. We do a failover, and that's okay, no big deal. And now they're realizing that it's a very big deal, and that can cost them major amounts of money.
Yeah.
I've got a question.
Sure.
What you're describing, I'm following what you're doing.
Okay.
I'm way behind you though. I haven't done a lot of the clustering yet, but I've got a rack in a data center with multiple power lines coming in with generators and all that kind of stuff. But I'm constantly wondering, at what point does it make sense to abandon all that and go to AWS or Rackspace or Google Cloud or one of those? Have you done any of the cost analysis to figure out what makes sense?
Yes, in fact I have. And there are 3 primary factors in my opinion for when it makes sense to go into the cloud. For me, that will be never, because of item number 1, privacy. My data is extremely highly sensitive. It's data that I could not have leak out even to the employees of the cloud provider. So it's an automatic no-go for me, just in my particular environment. But if any of you, have any of you ever actually read the terms of use for Google? Any of you actually read it? So how many of you are scared after reading it? So I read an example.
I don't go near it.
I read an example. I don't know if it's true or not. It sounds reasonable to me, which is why I'm scared. Basically, according to the terms of Google, if you send any piece of email through their system, they can use it for marketing purposes. Which means if a Coca-Cola executive sends the formula for Coca-Cola to another employee through his Gmail account, they can post it on the web as long as they say it's marketing. That just is scary to me. Forget the fact that I don't trust anyone. You know, their employees have access, etc. And so that's my primary concern.
What you're describing though is the basic level of service that we all get for free.
Right.
There
right.
are
Absolutely.
higher levels
Yes.
where you can get the data protection.
So the second item is cost, which is kind of what you were alluding to.
Yeah.
The problem that I have with cost is that when you start talking about paying for something monthly that I currently pay nothing for, which is the hardware, it becomes very difficult to justify. I could get a second rack at a second location, I could get BGP, I could create even 3 or 4 sites at some point, and still not have to pay for that hardware more than once. And that's, for me, that's the point where it becomes a maintenance cost, not a cash cost. Man, that server failed, I got to fly a guy out there, I got to replace the drive, I got to go out and mess with it, whatever it is. In our smaller environment, I got to get out of bed and drag my ass down there.
You still got to pay your host, you know,
Correct.
hosting on your rack and that's costing you too.
Correct. So in my instance, like I said, it's fairly a flat fee. I have a committed amount of bandwidth, I have a committed amount of power, and I can grow into that until I get to the absolute top of it, and then I can expand it. So I recently went from 10 megabit commit to 20. It cost me $4 a month more, literally. So at what point do I say, well, what's 20 megabits going to cost me on Google, because that's where they make their money? Yes.
So I just want to provide a little bit of information. So I work at a VMware environment.
Okay.
And VMware has a tool they call Business Manager, where you put in the assumptions on what the costs are. The very AWS costs this much, my on-premises environment costs this much for the various types of components, and it will dynamically move the virtual machine where it needs to go to make use of the lower cost, whatever your primary.
Basically least cost routing.
Yep.
Yep,
Yeah.
for the hardware, that's a fantastic tool. And if it works in your environment, nothing beats that. That's always the best way. The third issue for me was trust. Do I trust them to be up 24/7, 365? I mean, let's face it, Amazon and Google have a really good track record. But any of you remember Kim.com and that whole fiasco and just poof, even if your data was legit at the time that they shut all that stuff down, the government just said, too bad we took it, tough luck for you. And that is always a fear for me when it's in someone else's control. Not necessarily that entity isn't going to be a good steward of the data or the hardware, but that they might be doing something illicit or illegal, or they might go out of business because they made bad business decisions, etc. I mean, we could all argue here that Amazon and Google are doing it right and they're not going away. Lots of people would have said that about Enron. I mean, at the time, from the outside, everybody thought it was a fantastic company that was doing really smart things. So, depending on your level of commitment, you may be in 3 or 4 of those, and now the problem goes away. So don't just commit to Amazon. Have an Amazon stack and a Google stack. Now if something goes wrong over here, doesn't matter, your single point of failure is eliminated. In this case, the provider is your single point of failure. So again, there are ways of sort of overcoming these. Can you BGP a Google/Amazon IP pair? I don't know if you can. I guess if you own them with Aaron, it doesn't matter.
I think in some cases they're doing that for you.
Yeah, they might. I don't. Does anyone know? I don't happen to know. I mean, there are solutions, I'm sure, but you may be the first to do it.
I kind of like the idea of not having to worry about hardware failures and not having to worry about hardware of any kind of failure. I've got some hardware. I've got maintenance contracts on it. If I need a drive, I'll get it the next day. Drive down to the data center.
Right. So
I like to not ever have to worry about that, but I share the same privacy concerns that you do.
So my stack is in Vegas. So it's, you know, whatever it is, a 4-hour plane ride away,
Do you have somebody
travel.
out there to?
Nope, just the colo. I used to live out there, so that's where I built it. Here's the thing, I found I was driving there every 3 months. So if a hard drive failed, I just didn't care. I just said, it can wait, it can wait. Oh, 2 hard drives failed, it can wait, it can wait. Oh, 3 hard drives failed, I better drive down there. So again, every 3 months I schlepped down, did maintenance on the stack, and that was it. So I came out here for personal reasons, and so I'm just like, oh, well, you know, every 3 months I get a trip to Vegas, I get to write it off, have a good time, visit a bunch of friends, and you know, do a little maintenance on the hardware. You know, the data center will take packages and hold them in their secure storage for you, etc. And they do have remote hands if I allowed them into the rack. My fear is if something goes wrong, they bump a button and turn off a machine below the one they're working on, they don't know what they're doing. If I go bump the button, at least I have an idea of what it is and what it's supposed to be doing, and you know, wow, I just got 20 alerts on my phone, what just happened? So I'm a red dot cabinet, which is their high security. Their guys don't enter it unless you are physically present or you're on the phone with them while they're in the rack. So that prevents any confusion. They're not in there without me on the phone talking to them or one of my employees. So, you know, that is for my environment. Now I have a client that's in that same facility, and their data is super sensitive. They work with big data, companies like MasterCard and Experian, etc. They have your credit card transactions, literally. And so their thing is like their security, I mean, it's like insane, the level that you have to go through to access their stuff. So their CEO came to me, I want to save money, I want it more reliable, let's put it in the cloud. And I just turned to their chief security officer, because they have one of those, and I just said, you want to take this softball? Like, you know, I mean, it was just so obvious, you know, that it was impossible to do that for them. But I highly recommend it if you're doing something like e-commerce, where you're outsourcing all the credit card transaction data to a PCI compliant processor like Authorize.net or one of those other clearinghouses. So your data really is just your customer data. There's not really any risk to financial data. And you want high reliability. Google and Amazon are fantastic. They are, in my opinion, very expensive compared to, you could get a single virtual private server for $20 a month from someone like DigitalOcean or something, you know.
Sure.
And they'll be very reliable as well. The beauty and the major advantage is being able to scale. And that's where things like Docker comes in. Now that we're having, you know, automatic Docker deployments, Google even has a deal now, they'll load balance for you and scale for you. You just pay them and they'll automatically increase and decrease the number of nodes you need. It's actually really cool stuff. Highly recommend looking into it if you can. The idea behind Docker, just in case anyone here is not familiar, instead of running a whole server, you just, in a virtual environment, you just run your application. So you write your code, let's say in Ruby, and you just deploy a Ruby VM essentially, just runs your application stack, and you can run a Docker container that just has the web server. You have those two things connected. If one goes down, the other one doesn't. But you don't need a whole machine. You don't need the operating system to be installed. You don't need to manage any of the resources, the block devices, etc. It's a very cool idea. We'll see where it goes.
Yeah.
Yeah.
Earlier you talked about kind of clustering and virtualization working really well together.
Yes.
I was wondering, but when you're setting up kind of high availability, you don't want to put both VMs on the same physical hardware either. So I was wondering strategies for avoiding that.
So the idea is, let's just build off the web server idea. So I've got these parent load balancers and I've got 4 web servers behind it, right? So now instead of having these 4 web servers, I have 4 servers that have a shared block device, like a SAN, and I have the VM's data sitting in that SAN. The VM is running on machine number 1. When machine number 1 goes down, I just move it to machine number 2 and it continues running because its data is off over here. So it doesn't matter which machine it's actually running on. So the VMs in this case are running on individual physical hardware, but that hardware, none of those is committed to a single VM. The VM can move between. It's kind of like the least cost routing we were talking about before. Is this running on machine A at the moment, but when machine A goes down, it just starts itself up automatically in machine B. And there are some that will do basically ghosting. So you'll have machine A and machine B has your VM running, but all your traffic is going to A, and when A has a problem, it just shifts to B, and it's even sharing all your sessions. So we haven't talked about sessions and how to manage that. So in a web environment, which is a really good example, if you run PHP, PHP maintains the sessions in RAM. Well, if a request comes in and the guy gets sent to machine A, his session is there in RAM, but his next request comes in and gets routed to B, and his session is now gone. And so that's kind of what you're talking about, is when we start talking about deploying in a cluster environment, you cannot have anything specific to the compute node that that's sitting on. So you have to take your sessions now and move them, as an example, into the database. So now any of the machines can access it because it's in the database. So the same thing with the VM. Even though the VM is running in real time on machine A, all of its storage, all of its RAM, etc., is in a cluster. And that cluster for the RAM specifically could be something like a memcache cluster. Again, you can run them together and they'll keep all that data shared across multiple machines. So there's a few different solutions there. And a lot of them are built in. I mean, that's the beauty of virtualization, is the machines can move. That is specifically, in my opinion, the most powerful thing about the VM. Not that I can take this piece of hardware and divide it into 10. I mean, that's great. If I don't need the resources, I can just have a slightly lower bill. But the beautiful thing is I can move that thing around wherever I need to. I can scale it up. I can shrink it down. I can clone it. That's where the real power of the VM comes in. And when it's sitting on top of a hardware cluster, that VM can just move around. And so you don't have downtime. Yes?
So what software are you using for moving VMs around and that type of thing?
Well, I'm not running any VMs, so I run a pure HTTP environment, so I don't need to. All I have is everything is stored in the database, because all the HTTP servers, in my case Apache, can read the DB. It doesn't matter where the request goes. I don't have to bounce the machines around. So I'm talking more in the sense of what Google and Amazon are doing, and in fact what you're doing with the least cost routing of the VMs. Is you've actually created a cluster with the VM sitting on top of it, which is, I think it's a really elegant solution personally.
So you keep talking about the cost of doing these things, and yet when the cost, the dollar figures that you're citing all sound very low in an industrial scale. I mean,
Yeah.
there's a huge difference between, your own private little obvious thing, or if you're running maybe your own company, it's really all your own money.
Sure.
Or if you're running a standard, I don't know, 500-person manufacturing company or something like that.
Sure.
Now you're in a corporate scale, and it sounds to me like it would be prohibitively not, very cost effective to put it in, up in the cloud or, somewhere else where you have no responsibility for maintaining a room, even just, air conditioned and properly outfitted. Have you found that with your clients? I mean, are people just dumping their own corporate small data center in mass and going to hosting in clouds?
So that is a very unique question, actually, per customer. Just like we were talking about, if you have privacy concerns, then you have to figure out a way to deploy something that you consider safe and secure. Safe and secure and private. What you're kind of talking about is, well, I don't want to maintain any of this. I want to outsource all of it. And you can't do that. It depends on what you're trying to do. So are you talking about an e-commerce web page, or are you talking about employees' email? Employee email is a great example. I love that as an example. Everybody wants it everywhere. Everyone wants it to be 100% reliable. Everybody stores tons and tons of email, and they go, oh, that's like 3 years ago. I want to go find that, and they want to go hunt for it. So that is actually perfect for a cluster. Is if you've outsourced it to Google, you're trusting them to have that for you and deploy a machine for you and maintain their storage area network, which is where your email is sitting. If that email is sitting in your facility on a single machine, then you're relying on your RAID for redundancy. So the question that you're asking me is, at what point is it cost effective to say, I don't even want to maintain something on premise, and I don't want to maintain something even in a data center. I want to go pure cloud, let someone else be responsible for the hardware, which is what Jim and I were talking about. And what I have found is that primarily my customers are afraid of trusting somebody else entirely with their data. It's just too early for them to say, I have confidence that this is going to be there forever. And I try and actually fight that, because I think there are ways, again, of utilizing multiple vendors and then securing your data in that way. I deal with a lot of medical companies. HIPAA is a big deal. They don't want to outsource it, they want it in-house, they don't want to mess with it, they don't even want to talk about a third party. Everything's got to be in-house where their HIPAA compliance officers can take care of it and manage it. So if you're talking about manufacturing, you don't really care necessarily about that, especially if you're not talking about financial data. If you're talking about something else, there are a lot of good reasons to go into the cloud. What happens when your internet goes down? How do you access any of your data?
Well, you know, now, then you're host, but that's your single point of failure. So you have two internet providers, and you know,
Yeah,
there are ways
absolutely.
around that.
Absolutely.
You know, very few people are one single building anymore.
Right.
So you know, if you have 2 or 3 different locations, then you still have the same problem.
Absolutely.
Either that or you've got data centers in each one, and you know, it's.
And I would argue that it's actually more cost effective to have your own 2 data centers in your own buildings and have them connected by a private network than it would be to deploy out into the world somewhere the volume of machines you would need and the cost you would have to put it in something like an Amazon or a Google Cloud. They're not designed for that. Now, Rackspace is a little different. They're kind of more designed for what you're talking about. But here's the thing. Let's say you need some very expensive machines, you know, $10,000, $20,000 a piece. I mean, I have a client who bought a machine for over $100,000, a single box. So
In historical computing terms, well, that's not expensive.
they bought it last month.
Yeah,
But you can't get that kind of computing power from any of those other providers, is my point.
Okay.
You simply can't buy a 48 CPU machine from Google. They don't sell it. If you need that level of capacity, you can't buy it from them.
Now you gotta go to Rackspace.
Yeah, right, now you need a data center to put your own hardware into. And so that's all we're talking about is what makes the most sense for your needs. And your needs vary by customer. So what you're talking about seems like you don't have any specialized needs, and outsourcing to the cloud and letting them deal with it would be fine. But remember, they're just running a cluster. So we just call clusters different things. Today we call it the cloud. We used to call it grid computing. But the reality is, all Google and AWS is just a big cluster. That's it. It's just they're running it for you.
So yeah, somebody to manage that burden for you.
Exactly.
Yeah, what you're describing and talking about, if somebody was really smart, they would understand what you understand, and they would figure out some tables and cost analysis, and they'd offer a service. Come to this website, put your parameters in, and it'll probably cost this much in your own little garage, it'll cost this much in the back end of your building, and it'll cost this much on the cloud based on the parameters you put in. And double check us, but I think we're heading in the right direction. You know, somebody could offer a service like that, and for upward to or something, they'd run the calculation.
Right. And I think part of that calculation, which goes back to your point, is I find that typically the most expensive component of using something like AWS is the storage component. I mean, if you need 6 terabytes of storage, it's a lot cheaper to go out and buy a $500 6 terabyte drive and throw it into a machine than it is to buy 6 terabytes from them, which you will then pay for every month for eternity. So you have this drive, if it lasts for the expected 3 to 5 years, you paid for it once, and then you didn't have to pay for it again. Now, you may be saying, well, $600 is not a big number for me, and that could be, very possibly is true, but when it's $50 a month forever, and you need 20 of those drives, at what point does it become cost prohibitive to maintain it out there in that way? And again, that just is a calculation of what your needs are versus what they're selling today, and what happens when they change their terms of use or decide they don't want to be in that business anymore. I find it very difficult to move even from version 6 to version 7 of the OS, let alone move my entire stack from building A to building B, and I have done that. And that's just, anyone's ever done that, you've got to change your shorts. I mean, it's just scary. So if you're all up on Amazon, and then they decide to change something that no longer works for you, and you need to move to, say, Google or Rackspace, you know, that's also very scary, and you've left that in their hands. Anyone here know about the Windows 10 and how it's free, right? So, does anyone have free Windows 10? Yes, maybe you do. But what are they going to price it when the free is over? They haven't stated. So that's my fear in general with the future. We have no idea what Google and Amazon are going to do with their pricing. We have no idea if they're going to decide, oh, well, we can just keep raising our price by 3% a year or 5% a year, and people will pay it because they're dependent on us. All these data centers, we put them out of business. There's no more rack spaces of the world. There's no more little data centers anywhere. And now we got everybody by the short hairs. So is that going to happen? Probably not. I mean, that's not really what we're talking about here. But each of us in our different situation has to determine what's the best fit. I mean, small businesses always, I have the reverse argument with small businesses, which is, well, I'm small, I don't want to maintain something, I don't want to have a system administrator on staff, I just want someone else to take care of that, and my DevOps guy will write the software and configure the web server, and that's it, and my cost just went really low because I don't have to have another employee. That's usually where I have the argument, is the guy who's really small. And you're going the totally opposite way, and I appreciate that, actually. It's an interesting dilemma, but I need to know your specific situation to address it better.
I don't have one, but
Okay.
But it just seems to me like if you're being realistic about the cost of running it internally, that there's a lot more opportunity to put it out, because a room costs money, a person to maintain that room costs money, the air conditioning for it, the extra security that you need for it costs money, and then you're still relying on just the electrical service coming in,
right?
Which is one lightning strike away.
Well, and that is an argument about on-premise versus data center as well. I mean, if you've deployed on your premises, then you have to deal with the room and the security and the power and the generator yourself. And there is the argument to go to a data center. And that same logical argument continues, well, why not outsource the sysadmin as well, which is all we're talking about. On-premise versus data center versus cloud. And you can easily make the argument, oh, I don't want to maintain a room and a garden, power and security, that's why I went to a data center. And then somebody can come along and say, well, why are you doing a data center? You can also outsource the system administration and the hardware to somebody else. So there are very valid arguments for each of those three things, which is why there are deployments in all three of those environments. The key with the cluster and all of these solutions is the reliability, is that's what we're really talking about. Now, if we flip it and talk about the other side, which is high-performance computing, which is supercomputers and et cetera, there's a conference, actually, that they hold once a year. It's ELISA, which is the Large Installation System Administration Conference. And it's almost exclusively dedicated to high-performance computing. And the idea is somebody in New York figured out, I'm a little bit closer to the New York Stock Exchange than my competition, and I've got a fraction of a second before them to make my trades, and they made a lot of money. And I mean a lot of money. And suddenly that became a thing, and it was all about this specific building. I forget the address now, it's like 1 Hudson or something. And you will find that there are a ton of trading companies in that building because they are physically closer, and the speed of light is important in that environment, and they have these huge clusters and these huge power bills and this huge air conditioning, all about being 1/10 of a second faster than the other guys.
About, what, 11 inches per nanosecond?
It's something crazy. I mean, it is crazy. Some guy figured it out, and they made a lot of money. I mean, a lot of money. It was a really big deal. Yes?
Yeah, it's basically front running, and there was a mutual fund company in Canada that was doing transactions in Chicago. Well, it so happened that they sent the trade request out, and it went to one place quicker, so that they were able to determine what they wanted, buy what was available on the exchange in Chicago, and then resell it to the mutual fund at a fractional point higher and making a ton of money. So the workaround was they got a bunch of fiber optic cable and they put it in a box, probably about half the size of this table, and so that slowed down the transaction to the one location, and so that they were no longer being front-loaded.
So, I mean, we all know Superman 3, that's the whole idea, is if you're a fraction of a penny on every transaction, it's a lot of money. And that's all they're doing. They're just buying it at a fraction lower and selling it at a fraction higher because they have a half a second lead on the other guy. And that's all you need. And so...
It doesn't even need to be a half second. It could be a quarter second.
That's true. They're very small increments of time.
Hackers too.
Hackers too. Yeah. So that part of it, though, is the high performance, and that's not necessarily about reliability, that's about the speed. And so when we talk about those types of clusters, we have all those nodes operating on a single problem is typically what we're doing. And so there's message passing between the nodes, etc. And that's what supercomputers are doing. Is they're all working on the same problem, and they're just trying to break it down into pieces and divide up that computational power among a bunch of CPUs. Questions? Okay, good. Thank you.